Hi children, today you are going to learn ninth class chapter number 8 quadrilaterals in that exercise number 8.2. Before we are going to the exercise number 8.2, we have to learn some theorems which is based on parallelogram. Already we know the properties of parallelogram completely. Those properties are given as theorems here. Let us go for that. What are the theorems? Theorem number 8.1. The diagonals of parallelogram divide into two congruent triangles. So the diagonal of a parallelogram, suppose it is a parallelogram, the diagonal of a parallelogram will divide this parallelogram into two congruent triangles. That means the triangle ABC is congruent to triangle ACD. So it will divide into two congruent triangles. They will be occupying the same area. Okay. So it can be done by the diagonal. Either you draw the diagonal AC, you will divide into two congruent triangles like that. If you draw the diagonal BD, it also divides the two congruent triangles. Then theorem number 8.2. In a parallelogram, opposite sides are equal. As we know that in a parallelogram, opposite sides are equal. Here AB is equal to AB side is equal to CD side, and here AD side is equal to BC side. Yes. Now next, theorem number 8.3. In each pair of opposite sides of a quadrilateral is equal, then it is a parallelogram. Simple. In a parallelogram, opposite sides are equal. If opposite sides are equal, we can consider it as a parallelogram. If opposite sides are equal, then we can consider it as a parallelogram. You can also say that if opposite sides are equal, you can also say like a rhombus, rectangle and square. But all squares are parallelogram, all rectangles are parallelogram, or rhombus are parallelogram. So we can say that if opposite sides are equal, we can say it is a parallelogram. Then theorem number 8.4. In a quadrilateral, each pair of opposite angles are equal. In a quadrilateral, each pair of opposite angles are equal, then it is called as a parallelogram. Yes. Not only opposite sides, if opposite angles are also equal, that is called as a parallelogram. In upcoming questions, in the next exercises, so if opposite sides are equal, directly we can write it is a parallelogram. Or if opposite angles are equal, here also we can write it is a parallelogram like. Okay. So remember these two theorems and remaining these two also. These all four are properties of the parallelogram. Sorry. In the properties of parallelogram, we have learned all these four. Okay. Then we go for the exercise number 8.2. There are three questions in the 8.2 exercise. Let us solve this. In that, question number 1 first. Now let us go for the question. In the adjacent figure, ABCD is a parallelogram. ABCD is a parallelogram. Okay, let us draw the parallelogram first. Here A, B, C, D. Here ABCD, given that ABCD is a parallelogram. ABCD is a parallelogram and ABEF is a rectangle. ABEF is a rectangle. Where is the rectangle then here? AB, E, F, ABEF. This ABEF is a rectangle. So remember, in a parallelogram, opposite sides are equal. In a rectangle also, opposite sides are equal. Okay, this we have to remember. Now RTP. What we need to prove is, here we have to prove that triangle AFD. Triangle AFD. The triangle AFD. We have to show it is a congruent to triangle BEC, triangle BEC. Okay, let us prove this, children. Look at here once. First of all, let's go for the proof now. Let us take the triangle AFD. In triangle AFD and the triangle BEC. BEC. In these two triangles, as we know that here AF is equal to BE. AF is equal to BE. How? Opposite sides of rectangle. Opposite sides of rectangle. Sides of rectangle. They are opposite sides of rectangle. So here AF is equal to BE. Then also here AD is equal to BC. AD equal to BC. How can you say this? Because these two are opposite sides of parallelogram. Opposite sides of parallelogram. Then we can write here one more thing. ABEF. Here. ABEF. That AB equal to EF. AB equal to EF. And also here this AB is equal to DC. So I can write now FD equal to EC. FD equal to EC. I can write now this FD equal to EC. How this FD equal to EC? Let me prove it here. Let us go further. So this AB equal to EF. AB is equal to EF. This AB is equal to EF. Opposite sides of rectangle. AB and EF are opposite sides of rectangle. So AB equal to EF. Where EF we can write, this E and F we can write ED plus DF. ED plus DF. Then now again this AB is equal to CD also. Why this AB and CD are opposite sides of parallelogram? So AB is equal to CD. This CD can be written as DE plus CD can be written as CE. CE or EC plus DE. That means ED plus CE or EC. Okay, ED plus EC. So in this, see, we can make it equal now. Here AB equal to AB if you make it. Then ED you cancel it. Then we get here DF or FD. This DF I can write as a FD. FD is equal to EC. And also you want to equal them. This one is equal to this. ED plus DF equal to ED plus EC. Then ED will get cancelled. DF equal to EC. That's what DF or FD is equal to EC. That's why we can write this. Now we can say that therefore the triangle AFD is congruent to triangle BEC by the rule of side. By the rule of side rule. By the side rule, these two triangles are congruent. So finish it. Very simple that opposite sides of parallelogram, opposite sides of rectangle, and the remaining two parts also will be equal. So by the rule of side, these two triangles AFD and BEC are congruent. So next one, this is second one. So look at the second one. Show that the diagonals of a rhombus divided into four congruent triangles. So we have to show that the diagonals of a rhombus will be dividing into four congruent triangles. How can we show that? Let us go for that. Now let us take a ABCD. Let us take here ABCD is a rhombus. ABCD is a rhombus. As we have to show that here, the diagonals will divide into four congruent triangles. Okay, here diagonals RTP, will take it. What we have to show it here? RTP, the diagonals of rhombus, the diagonals of rhombus divides into four congruent triangles. That means we have to show here the triangle AOB is congruent to triangle BOC is congruent to triangle COD is congruent to triangle DOA. What are these? If ABCD is a rhombus, we get this. Let's go for the construction and you can understand this. Construction, let us take. Here, let us write here. Okay, suppose it is a ABCD is a rhombus. Take ABCD is a rhombus. Suppose A, B, C, D is a rhombus, and these two AC and BD are diagonals intersecting at O. Here, proof ABCD is a rhombus and AC and BD are diagonals intersecting at O. Now we have to show that these four triangles are congruent. That is what I written. A triangle AOB, it should be congruent to triangle BOC, it should be congruent to triangle COD, and it should be congruent to a triangle DOA. So this is what we need to prove. See that how we are going to prove that. Let us go for that. Now let us show that first. Okay, let us take this triangle first. In triangle AOB, and triangle COD. In these two triangles, let us take. So what we can say in these two triangles? See that in triangle AOB, this angle will be equal to this angle because the opposite sides will be equal and parallel in the rhombus. Opposite sides are equal and parallel, no? Here AB is parallel to CD and AC is a transversal because here AB and CD are parallel lines. AC is intersecting these two parallel lines. So alternative angles are equal. Just remember. Then here similarly angle B and this angle D will be equal. Same alternative angles. And AB will be equal to CD because all the sides are equal in the rhombus. That is what I am going to use it now. So here angle BAO is equal to angle DCO. How? Alternative angles are equal. Alternative. ఎందుకు ఈ రెండు parallel AC అనేది diagonals అవుతే alternative angles are equal. Alternative angles. Let us write. Then we write here AB is equal to CD. AB is equal to CD. All sides are equal length. Opposite side are all sides of rhombus are equal. So all the sides sides of rhombus are equal. So according to that, AB is equal to CD. Now angle B equal to angle D. Why? Because here AB and CD is parallel. Now here BD is a transversal. If BD is a transversal, these two alternative interior angles are equal. So angle ABO, angle ABO is equal to angle CDO. Same again, alternative angles. It's a interior angles you write here, suppose interior angles, alternative interior angles and write. Okay, alternative interior angles are equal. Now we can write, therefore the triangle which we have taken, triangle AOB is congruent to triangle COD. Triangle AOB is congruent to triangle COD by the rule of angle side angle rule. This is equation number 1. Angle side angle, they are common. Now similarly we can write ఇది ఎలాగో చేసాము. See, 1 and 2 are congruent. This 3 and this is a 4. This 2 will be also same congruent. How? See, this angle here, this angle will be equal to here, and this angle will be equal to here, and these two sides will be also equal. Similarly, we can write now a triangle BOC is congruent to triangle AOD or DOA by the same angle side angle rule. This is equation number 2. So these two angles are congruent and these two angles are congruent. Now we have to prove it. Any one, if 1 equal to 2 here, 1 equal to 2 is completed, 3 equal to 4 is completed. If you show that if 1 equal to 3, if 1 is equal to 2 and 1 equal to 3 and this 3 equal to 4, that means this all will be equal. 1 అనేది 2 కి ఈక్వల్ అయింది, ఓకేనా, అండ్ 1 అనేది 3 కి కూడా ఈక్వల్ అయింది, అండ్ 3 అనేది 4 కి ఈక్వల్ అయింది. అంటే 1 is equal to 2 is equal to 3 and this 3 equal to 4. ఇలా వస్తుంది. 1 is equal to 2 and this 1 is also equal to 3 and this 3 already equal to the 4. So 1, 2, 3, 4, all these will be equal. According to that, now let us take it, this 1 equal to 3 అని చూద్దాం, లేకుంటే 2 equal to 3 అని చూపించండి ఏదన్నా, ఆర్ 2 equal to 4 ఆర్ 1 equal to 4 ఏదన్నా ఇంకో రెండు ట్రయాంగిల్స్ కాంగ్రుయెంట్ అని ప్రూవ్ చేద్దాం. సో now in triangle, now I will take this AOB triangle and triangle BOC. In BOC triangle, these two triangles, let us see that we will prove it as a congruent. How can we prove it as a congruent? Let us see now. We go for side. Yes, by the side angle. From the proof number 1, see, from the proof number 1, these two from directly I will write that. Okay, we go for that. Here AO is equal to OC. AO is equal to OC. How? From proof number 1 by CPCT. By the CPCT rule. What is CPCT? Corresponding parts of congruent triangles rule. See, these two triangles are congruent. AOB is congruent to COD. These two triangles are congruent. Then their corresponding parts, AO is equal to OC. Now we can write that. AO equal to OC. Then here AB is equal to CD. Okay. All sides are equal in rhombus. Okay. Then again here OB is a common side. This side will be equal to this and these two sides are already equal, and OB is a common side. OB is a common side. OB equal to OB. It is a common side. Common side. Now we can write that the triangle AOB is congruent to triangle BOC. Is congruent to triangle BOC. These two triangles are congruent by the rule of side rule. This is equation number 3. From equation number 1, 2 and 3, we can say that, see, this AOB, triangle AOB is congruent to triangle BOC, and this AOB is congruent to triangle BOC, and this AOB is triangle congruent to triangle COD. Now this BOC is congruent to triangle DOA. That means all these four triangles are congruent. Hence, therefore, the diagonals of rhombus divide into four congruent triangles. Therefore, the diagonals of a rhombus divides into four congruent triangles. Four congruent triangles. Hence, fruit. See? Hence, fruit. So this is the solution. You might be have the same question in the exercise number 8.3 or 8.4. We have to see. So you just go through this same thing, so that the formed by midpoint rhombus successfully the rectangle. Okay, I will tell you where it is again. In the next exercise, I will tell you where you get the same problem. Now, next one. The last question of this exercise now. You go for that. In a quadrilateral ABCD, the bisector of angle C and angle D intersect at O. The third one, solution. Given that ABCD is a quadrilateral, ABCD is a quadrilateral, ABCD is a quadrilateral, and angle C and angle D are intersecting at O. Angle C and angle D are intersecting at O. Intersecting at O. So RTB required to prove that. What we need to prove here? Angle COD. Angle COD equal to 1 by 2 of angle sum of the angles A and B. 1 by 2 of angle A plus angle B. Now according to the question, children, what we do it here, look at once. Now we go for construction once. We go for a construction. As he said, ABCD is a quadrilateral. No, let's go for any kind of a quadrilateral here. So whatever, maybe it is a whatever kind of quadrilateral. Let us go for A, B, C and D. ABCD is a quadrilateral, and we know that in every quadrilateral there will be four angles like this. Now angle C and angle D are intersecting at O. So the bisectors of angle C and angle C. The bisectors of, here we are to write, the bisectors of angle C. The bisector of angle C, that means angle C में two equal parts का divide करेंगे. The bisector of angle C and the bisector of angle D are intersecting each other at O here. They intersecting each other at O. So we'll getting like this. So we go for the proof now. Here you concentrate the sum of four interior angles of a quadrilateral. The sum of four interior angles of a quadrilateral is equal to 360 degrees. So angle A plus angle B plus angle C plus angle D equal to 360 degrees. So what I will do it now, this angle A and angle B I will make it a pair, and angle C and angle D I will make it a pair. So what I will do now, see this angle A plus angle B I will transfer the side. So angle C plus angle D equal to 360 degrees minus of angle A plus angle B, because we require this angle A plus angle B towards the RHS side. So we will write like this. But what I will do, by dividing by 1 by 2 on the both the side, let us divide by 2 on both sides. Let us divide by 2 on both sides. We get, see here we are dividing by 2 to the angle C plus angle D. Here angle C plus angle D by 2 is equal to this 360 degrees minus of angle A plus angle B by 2. So this the angle is, this the 2 is dividing for both angle C and angle D, and here also this 2 is dividing for angle C and angle D. So what I will do here, this 2 I will take it common, 1 by 2 of angle C plus angle D equal to here 360 degrees by 2 minus 1 by 2 of angle A plus angle B. So this 2 is dividing for both, no? So let us divide 360 by 2 minus 1 by 2 of angle A plus angle B. That means this 2 is dividing for this both. 2 ones are 180 degrees. So here 1 by 2 of angle C plus angle D is equal to 180 degrees minus half of the sum of angles A and angle B. This we keep it as a equation number 1. That we keep it as a equation number 1. Now in triangle COD, here you can see the one triangle COD. Now in triangle COD, here sum of 3 interior angles of a triangle equal to sum of 3 interior angles of a triangle is equal to 180 degrees. As we know, sum of 3 interior angles of a triangle equal to 180 degrees. No? Here half of the angle C. So here half of the angle C plus here half of the angle D plus this angle O. 1, 2, 3. It is not complete angle, no, to write angle C. It is a half of the bisector of angles. Bisector of an angle. So half of the angle C and half of the angle D plus angle O. Angle O in the sense here COD. Angle COD equal to 180 degrees. So from these two steps, okay, what we do it here, this angle COD will transfer the side. Angle COD will transfer the side. Here 1 by 2 will take out common. 1 by 2 if you take out common, then here angle C plus angle D will be left over. Angle C plus angle D will be left over. Any sum 1 by 2 common this angle. So angle C plus angle D is here, and here 180 degrees. This angle plus angle COD become minus angle COD. Plus angle COD you transfer the side become minus angle COD. This is equation number 2. Okay, from equation number 1 and 2, we can write that. What you see the equation number 1 and 2 closely, what you can say? LHS are equal. 1 by 2 of angle C plus angle D. 1 by 2 of angle C plus angle D are equal. Let us make it RHS will be equal. LHS equal one RHS ni equal chedam. So 180 degrees minus angle COD is equal to here 180 degrees minus half of the angle A plus angle B. This is equation here and the rest of equation here. And 180 degrees will be get cancelled. Here minus and minus get cancelled. Therefore, angle COD equal to half of the angle A plus angle B. Hence, fruit. I hope you understood this clearly now, how we got the answer. With this exercise is got completed. So, we'll meet with our next exercise 8.3 in our next video. Till that time, keep practicing these 3 questions. Bye children.